So today we're just going to talk about the influence of some recent studies we've had in winter wheat and how we can work on extending using the implementation of the sensor-based nitrogen rate calculator and extending that to you all and how we implement it. So we've had a little bit of a wet fall. For many of the producers and us trying to put out research trials, we were trying to put out research trials right here before it rained, and then right here before it rained, and then right there before it rained. So we, for some of our locations, we didn't get a lot of nitrogen fertilizer put out until mid to late November, just due to the moisture that we had, late plantings and that kind of stuff. And so this leads, and for many of you who are in the same boat, who are looking at this, many of you may not have out pre-plant fertilizers and might be a little bit worried. Oh, crap. As of right now, we're in the climate we are right now, we're not going to have any growth until about February. So many producers have been stopped by rainfall, like I said, from producing or allowing to apply any fertilizers. And this leaves us to question, are we missing out on some yield by not hitting with some nitrogen now? We do know that if you're using the enriched strip method that we push out a lot, that you can apply in season using the green seeker technology, and then using the sensor-based nitrogen rate calculator, you can apply in season. One of the questions is that how late can we go? In order to use the enriched strip method, there inherently has to be a deficiency. Are we going to lose some yield by waiting too long? Researchers' message has been for the recent years that in favorable growing conditions, applying within 2 to 3 weeks of visual deficiency in field is okay, that we can get away with that, but you do not want to apply any later than Feeks 5 or first hollow stem stage. But some more studies that we're doing now are telling us that we might have some more options. Researchers are really tasked with being able to use the enriched strip method and the SBNRC to become more accurate in our yield predictions and more accurate in our nitrogen recommendations. So the first of these two studies we'll talk about is just the yield prediction model. Just the objective was to determine whether the ideal point in the growing season where NDVI readings are highly correlated with grain yield. One of the big caveats of using the calculator is that we need to be able to accurately predict how great our yield is going to be, and therefore accurately predict how much nitrogen we need to put out on the field. This trial was, this study was done alongside many other studies, but it was just, took comprehensive NDVI sensor samplings from Feeks 2 all the way to Feeks 11 and correlated to see how accurate these NDVI readings were with yield. The two locations that were looked at were Experiment 222 in Stillwater and then Experiment 502 in Lahoma. On both of these locations, we're looking at around 90 to 100 growing degree days into the growing season is where we reached about the peak of our yield prediction model, about 95%. And so 90 to 110 growing degree days is right around that Feeks 5, up a little higher to the Feeks 7 stage. So for the NDVI sensor and the models, this says that we have to wait pretty late in season in order to get that highest accuracy of the yield prediction. Can we still apply at these late stages and get the yields that we're looking for? So then the second study that we'll talk about is just the nitrogen timing study. The objective was just to determine the impact of delaying a top-dress nitrogen application in winter wheat, and to see what kind of effects this has on our yield as well as our proteins. So for the plots for this, we started out with a check which never received any nitrogen from beginning to end of this trial. This is so we can compare everything back to. Followed by a pre-plant application that we would have put out. Then from there, and all these were the same rates depending on the location at what rate that we put out. Generally it was around 90 to, I think it was about, the highest rate was 90 pounds per acre. Is that right, Joel? Yes, okay. So once there was a visual difference perceived between the pre-plant and the check plot, we then put out our treatment 3, which was 0 degrees after visual difference. So that's what 0 DAVD is. If you hear me talk about growing degree days, I'll be referring to DAVD, days after visual difference. And so once we get that first visual difference, we put out our treatment 3, 0 degrees. 0 days. Then we pulled out one 7 days later, followed by 14 and up to 63. Now the application dates of all these nitrogen rates varied throughout different fields, as this was based on that location. So there were fields that we would start out and our first visual difference would come out in November the 10th, and the last application was February the 22nd. Then we also had trials that our first visual difference didn't come out until the very 1st of February, and we didn't finish the trial until the 1st of May. And so we had a lot of different, you could see there's a lot of variability in the timings here, which relate again to the growing stages. This was a location, this is our Lake Carl Blackwell location, and I'll just show you the treatment plan here. We go all the way up to 63 days after visual difference, and you can see that in the field, and it was very easy to see when we take our green seeker over and get values for that. For this location, if you look at our, so yield is on the left side, and then our proteins are on the right side, and so these points are our protein, and then the bars indicate our yield. For our Lake Carl Blackwell, one of our Lake Carl Blackwell locations, does not seem that we are losing any yields across, especially in our growing degree days and our early ones between, I'm trying to remember, this was up to 63 growing degree days after visual difference. But we were not losing any yield whenever we delayed nitrogen application. Late in season, after we've surpassed the peak 7 stage, we start losing yield. But we are still increasing our proteins, which kind of leads us into wondering, another study might be into looking at if producers are starting to get a lot more premiums just from proteins, we could look back into this further. But as many of the locations in this trial, we never, delaying nitrogen application did not decrease yield at all. Most of the time we would see an increase in the yield. This chart shows all the locations that this trial was put out, as well as the yields and the proteins. And the color indicates whether it was significantly different from the pre-plant application or not. And for all locations besides Lahoma in 2018, we were always seeing an increase or no change in yield. We did have a late application in, that was the graph that I had shown you before. We did see a decrease in yield on the very late application, and then these two we had a decrease in application as well. Looking at our protein differences, we are seeing protein increases across the board when we were applying nitrogen later in season. This location at LCB 2018B, we saw a decrease, and that was very late application of nitrogen. That was much further than when the plant was uptaking any more nitrogen. It was maturing at the point that that application was put out. So once again, most of the differences in that was just based on the nitrogen application date that we had. So when we put all this information into a model and we started taking a look at it, so all of these, this is all normalized for treatment 1, which means the check. So just to set up this table, any value, so this one line right here means that it is no different than the check, or than the no nitrogen applied, right on this line. Anything above that means that we have done better than the check. Anything below that means we've done less than the check. So as we see an increase of this line here, this means that further in, as growing degree days are on the x-axis here, as our growing degree days increase up to about 80 to 90, is where we're reaching that max line there of about 1.5 times the amount, or 1.25, excuse me, times the yield of the check. We've done this again with the treatment 3, meaning 0 degrees after visual difference normalized. And once again, anything above that point, that one line means that we've increased our yield. Anything below that says that we've decreased it. And we're still looking at around 80, or actually we're looking at about 100, it's better if I can see it from here, about 100 growing degree days is when we're really reaching that maximum point. around that Feek 7 stage. So a significant find of this work was that the ability of wheat to reach the maximum achievable yield levels was in no way related to the point in time at which the crop undergoes nitrogen stress, but the growth stage of the crop that was most directly correlated with the grain yield recovery. Both the yield model and the nitrogen timing study suggest that between 80 and 100 growing degree days after planting is when we hit our maximum yield, right around that Feek 7 stage area. One thing that we did not see in this study was a very wet year. We're hoping maybe this season, as we continue to do this study, we're going to see a wet winter and see how that applies to this, see if that really changes how this trial pans out. Because we just had two fairly dry, or a normal year and then a drier growing season here. So as we extend the nitrogen-rich strip and the SBNRC, the data suggests that the optimum top dress timings are around 80 to 100 growing degree days after planting. In 2 years and in varied environments, nitrogen could be delayed until late March applications. This moves us from less hesitant and concerned to more confident that we can allow producers to delay nitrogen application. And this is very significant to any producers in the southern Great Plains and in Oklahoma. Looking further, we might look into earlier planting dates and see if we can apply nitrogen in the fall growing season as well into the top dress timings and see how that relates to that.